We're almost there, y'all. Polar. This is it. This is it. We have 12.2, which is a refresher of polar coordinates. And if you don't know what polar is, I didn't either in Calc 2. And this is where I learned it. Some of us were fortunate enough to take a trigonometry course or a pre-calculus course where the teacher covered it. So you've seen this before. And if you've seen it, awesome. This shouldn't be so bad. But we're going to kind of just get everybody up to speed to where we're all on the same level playing field. So 12.2, there's no calculus. We're basically doing the same stuff we would do in a trigonometry class. And, well, since you've already passed the Calc 1 class, I'm sure you got the skills to be able to pick this up. So, yeah, 12.2. We're just hanging out, learning something new. No calculus. Calculus will come in 12.3, and that's when we'll start doing that with polar. So, let's see what's going on. What are we doing? Why are we doing this? So, we're used to something called the rectangular coordinate system. All right, X's and Y's. Oops. That never makes it better, just writing over it. We're used to things like this. If I give you an X comma Y, like maybe we do a 1 comma 2. 1 and 2, and then we make a point. All right, well, this is what we call the rectangular, huh? All right, you move up your 2 units, you move over by 1. Kind of like makes little rectangulars, hence rectangular. It's what we're accustomed to. But now we're going to move into a new sort of points, which polar coordinate system. Or we can think of it as like circular. Wow, that's not even close. Circular. Except we're going to have a new coordinate system, and there's going to be much more that pops up. So instead of writing an X and a Y, we're going to write an R and a theta, where R is the radius, or let's think of it this way. How far from 0, 0 in a rectangular? How far away are we? Theta is the angle. So for example, let me just show you. Let's say the radius, let's make that 2. And let's make the angle pi over 3. Now we're just going back to trigonometry. You know the unit circle, don't you? At least the quadrantials. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Not so bad. So what we want to do is, I like to read them right to left. I like to do the radius afterwards. So to find the point, we're going to draw a line. The line's not actually there, but it helps us to see it. I'm just going to make an angle at pi over 3, 60 degrees. And I'm going to make a little dot right here and say that this length from the origin is 2 units. So we find the angle. And then we just make however long that piece is, that line that's not actually there, we'll make it the 2 units for a radius. In actuality, it's just a point. 2 comma pi over 3. But it's very helpful to just draw the line end, because then you can see, you're like, oh, dude, I'm moving from pi over 3. Cool. Now, why do we want this? Why the hell would we want this? I'll give you just a bit of an example here. I'm going to take you back to Calc 1. I'm going to take the unit circle and ask you, all right, cool. Find the derivative of this function with respect to x. Do you remember all the work you'd have to do? You know what I mean? Find dy dx. And this is for something simple. We'd have to go 2x, and then this would be, 2y, but, that's implicit. Derivative on 1 is 0. We'd have to divide everything over, and dy dx is equal to negative 2x. I know I'm going fast. I'm purposely going fast. Is equal to negative x over y. So then we need any value of x and y for us to be able to find the slope of the tangent line, or any value of x. That takes work, and that's about as simple as they get. And they don't get much simpler than that. But we're going to learn that x squared plus y squared is just the radius squared. So we have that the radius is 1. Do you know how simple it is to do calculus on that? You know what I mean? You know what I mean? So circular is going to be helpful. Now, I'm not going to go any further with it because trying to find, well, the radius is 1. It's not changing, so taking a derivative doesn't make any freaking difference. But this is somewhat of the point. Now, let me take you to Desmos. Y'all know Desmos? You're not going to be able to see the top part of it because I keep my screen kind of clipped, I guess. Cut, cropped. I don't know. So let's go to Desmos. Oops. So when we're stuck, you might want a little bit of help, maybe some graphing. A little bit of help graphing. Let's show you some. So on the right-hand side, top right corner, where we got it says graph settings. Click that little wrench. You can see we're in what's called rectangular. You can see all the little squares because all squares are rectangles. Not all rectangles are squares though. And we hit that. Now we go over and you see the bullseye? Click on the bullseye. Dude. Look at this. It's now telling us our angles. Our pi is over 6s, our pi is over 4s, our pi is over 2. And look, it's like a bullseye just telling you the 2 units away. So if you ever want to, like, I don't know, graph a function, we're going to start with points. So don't worry, we're not doing this quite yet. But we can make all kinds of, go away. We're going to learn that we can create equations out of this. Like maybe I say r is equal to 3 sine of, I got to find a theta. And look, it makes like a little circle. Maybe we do 2 minus 3 sine. Wait a second. Let's do 2 plus 3. What's that look like to you? I can never help myself. I'm a child. I'm a child. What does that look like to you? It's called a limison with an inner loop. But if you ever take Professor Balagai and he puts this thing up and he asks, what is this? You say it's a butt. Doesn't that kind of look like a butt? Kind of looks like a butt. And look, there's like a little, what is that? It's almost like there's a little hole. Oops, now we're getting dirty. Let's not do that. But hey, I'm just showing you as we go through it, if you're ever confused and you want to graph something, take a look and see what it is. Beautiful. This is what we're going to mess with. So let's go back. Now, polar is used. It's really powerful for a couple of things. One, more than anything. Polar is great for non-functions. You know, like x squared plus y squared is equal to 1, right? Because it doesn't pass the vertical line test, right? Which makes it to where we have to do implicit on anything. But as we move forward, we're going to learn a little bit more about this, that we're going to be able to find the slope of the tangent line anywhere very simply by knowing polar. And everything you're moving into, if you're going to Calc 3, is 3-dimensional stuff like this. And it's only going to get more complex. So let's make sure that we have a solid foundation. So next one, we'll actually do some problems. We'll start to mess with it. You'll see it's not so bad. You don't just have to listen to me babble on. But I wanted to give a little bit of an intro to this. We got a new coordinate system. We got a new x and a y. It's r and theta. Right? R comes before t. X comes before y. We'll think of it that way. And I'll see you in that next video.